Hi everyone, welcome back to a Fresh Thinking podcast. This is a podcast where geoscience meets mining engineering. And I'm your host today, Greg, a senior consultant with Snowden Optiro. So today's topic is MSO, the Mineable Shape Optimizer. With me is Hamish. Hamish is our managing consultant at mining department. He got more than 30 years mining experiences. And welcome, Hamish.
Thanks, Greg. Great to be here.
Okay, so to set up the thing, I want to ask the simple question: what is MSO, and why do we need to do that?
Yeah, so MSO is a mineable shape optimizer. So predominantly used for underground, but has a lot of different applications. A very powerful tool, but a simple approach. It's designed to create mineable shapes underground, which are typically either open stopes or any openings, as long as we can put some sort of geometry around it. In the past, we used to hand draw sections on sections of complicated ore bodies and try to model an economic cutoff grade to an underground mining method. These days, we have an automated tool that does a lot of the work for us.
Cool. So, what's the economic logic inside MSO? Because I know it's used to assess economic value for those shapes, whatever the geometry we're gonna put in there. So, what's the logic behind that?
Yeah, good question. So the MSO relies on us understanding exactly what the material that we want to mine from underground costs us, and it needs to cover all of the costs to blast, to bog the material out, to haul it to the surface, and then to process it.
Okay.
And all the administration costs that go with all those activities. It gives us the ability to choose whether we leave it in the ground or do we mine it.
Okay, cool. That's very clear. And then, what are the inputs from us, the geologists, for you guys to do this MSO?
Yeah, so the MSO is a powerful tool of wrapping a a generic stope shape that's replicating how we'll mine it in the future. But a big part of whether we mine the stope or not is understanding the geology. So understanding do we have multiple narrow veins, or is it a massive deposit? What are the complexities of the geology? Also, what is the structural nature of the geology? And when we blast it, is it going to stay up? Is it going to fail?
Okay.
All of these questions we need to talk to the geologist and understand what's in the ground before we start putting an MSO around it.
Okay. So, so when we do the handover, apparently we need to give you a block model, and that should contain the different material types, the grade value, whether it's like the gold, it's just single value, or the polymetallics. We get multiple elements. Some of them gonna contribute value, but some of them are deleterious elements actually.
Yeah.
So we need to put all those information in there. And so for you guys to assess, to start the MSO work. So I always think it is important to understand the logic behind, so we can better use the tool. So what is the engine under the hood of this MSO? How does that actually work? Like, imagine we're software. How does that software work
Yeah.
behind?
and I can't explain the software algorithms, but to simplify the process is
Exactly.
that initially it goes back to the sections and it breaks the problem into a grid, and assess what is the maximum amount of material that you can mine that still meets your cutoff grade.
Yep.
As you said, it needs to also work across the broader resource as well. So the MSO tool has evolved over the years. I guess initially it would have operated on the stope scale, but now there's a lot of tools in there to work out the whole level, the whole mining area, so that your stopes are continuous.
Okay, cool. Thanks. And so if we want to compare the open pit and underground scenarios, for open pit, it's pit optimization. We want to generate the ultimate shell to assess, what could be the ultimate value we're gonna get by the end of the project. But is there anything similar in the MSO, or what's the similarity? What's the difference?
And I guess all of these problems need to be mapped out. With an open pit optimization, you can quickly work out the ultimate NPV that you'll get for different size pits. The same exercise needs to be done for the underground. So there's always not a simple solution, but it's just working through the problem. How do we evaluate the time value of money to either mine from the surface through surface methods, open pits, or to go underground? And there's a range of options as well. Do we mine the underground first and then the open pit? The open pit before the underground? Do you mine the two at the same time? These are all things to map out in a sort of study pipeline.
Thanks, Hamish. That's really great. And so I occasionally see that people use MSO, this tool, to assess narrow veins in the open pit scenario, because looks like it can optimize dilution ratio. But do you want to talk about it?
Yes. So the other thing that MSOs are very good at is creating mineable widths. So this is very useful for very complex, narrow-veined open pits.
Exactly.
Where we know that an excavator bucket may only be 3 to 4 meters wide. If we've got a 1 meter vein, we know that the dilution is going to be very width dependent. And that's something that MSOs do very well, is mapping or putting a width-based polygon or shape around an ore body. So always fit for purpose, a slightly different process to some of the other dilution methods that you can use for open pits, but another tool in the toolkit.
Yeah, exactly. And I know most of the time we just apply a dilution skein using a fixed length, for example, half meter both ways, hanging walls, foot walls, or 1 meter, and then claim that everything inside this dilution skein is probably what the mineable resources we're going to have. So when we compare this dilution skein against MSO, what's the advantage of MSO?
Yeah, so I mean, again, it's all another tool in the toolkit. I think all these methods you need to appreciate at times. What do they bring to the parcel? And all methods have their strengths in terms of complexity, time to set up, and value. At the end of the day, you're just trying to replicate what is going to be sent to the mill and using the best tool to forecast what those dilutions and all losses might be.
Cool. And so apparently this MSO that involves quite some parameters. And do you guys always run some sensitive tests on it?
Yes, so depending on the level of study, the more sensitivity work that we can do improves the accuracy of the result. We'd like to spend months doing sensitivities, but as you get into sort of feasibility studies, it's probably quite prudent to understand the flexes of the different parameters that we use for MSOs.
Exactly. So can you talk about the common pitfalls, like when we use this MSO tool, what are the common errors and what should we care about?
For an operating mine, it's always the power of the MSO is working through how close does the MSO replicate the end result, because that's what you're trying to achieve. So that's the luxury of operating mines, that they've actually got an output they can compare to. So pitfalls would be not doing that comparison, sort of believing that you've got the best information, knowing that mining methods and operating techniques do change over time. And I think pitfalls are using expecting every ore body to be exactly the same. So every ore body is slightly different. It's understanding what parameters work for some ore bodies and not for others.
In other words, there's no one size for all parameters, magic parameters to use everywhere. So you have to assess that case by case.
It's just another tool to understand what works best.
Exactly. So now, when we hand over our part of the work as a resource geologist, we hand over this block model to you guys. Can you give us a gold standard example what we should do to make this workflow flows actually?
I think any model handover comes with feedback from the mining engineer, and typically a new model is a change from the last model. So if there's in the underground world, if there's a new MSO assessment, it's comparing that to the last one and reporting that back to the geologist. So changes that the mining engineers see are in line with the changes that the geologists see. And it's also just having a discussion where the geologists and the mining engineers are in the same room to discuss what is different.
Yeah, in other words, the communications are two ways, not just one way.
Exactly.
So that's very important. And any real-world tips? I know you are the expert of this topic, so.
I think it's just treat every geology scenario as a new challenge. Learn from what works and develop from there.
Okay, so to put it all together, and can you give us a mini workflow for the MSO? What kind of the input? What do you do, and then what's the output, and how should we use that, or as a geologist, or how will that work will be used?
Yeah,
afterwards?
I think the workflow always starts with the block model. It's understanding all the fields that within the model, understanding what's driving the resource model. I mean, that's the critical input. The other critical inputs are working through all the economic assessments. Do you understand the cost per tonne of taking the material out of the mine, as we've previously discussed, but also the revenue per tonne? And the revenue may not just be the pricing, it's also the processing recoveries and any other sort of constraints that the more that you front load your assumptions for the MSO, the more powerful the tool. And it's also understanding any other constraints, as their material, as their spatial. So the workflow is getting all of the inputs in front of you so that then you can flex the tool. And when you've got outputs from the tool, that you're sort of understanding what it's giving you, and then work through sensitivities and report back, having constant communication with not just the geologist but the other stakeholders as well.
I think that's a really good point. MSO is a tool for us to tell a story, not just some numbers out of this. And thanks for listening. And if you're interested in this topic, stay tuned, and we are having more episodes on the similar topics in the near future. And thanks, Hamish, for joining us. If you want to listen more of Fresh Thinking podcasts, we have that on most of the mainstream platforms. So stay tuned.